Hi everyone. We have a quick announcement before the show today. SmartLogic, the custom software shop behind this very podcast, is hiring for a mid-level Rails or Elixir developer. Our team is fully remote and this position is open to applications from anywhere in the United States. You can read the full job description and apply at smartlogic.io/jobs. Okay, now on to the show.
Welcome to Elixir Wizards, a podcast brought to you by SmartLogic, a custom web and mobile development shop based in Baltimore. My name is Alex Housand, and I'll be your host. I'm joined by my co-host, Sundi Miet. Hey, Sundi, what's up?
Hello there.
Unfortunately, our producer, Eric Ostrich, is out today, so Sundi is going to be our jack-of-all-trades co-host and producer. The season is Beam Magic, and we're joined today by special guest, Isaac Yonemoto. Welcome, Isaac.
Hey guys, how's it going?
Pretty good. How are you doing today on this fine Wednesday?
I'm doing okay. I've just had to deal with one of our. Maybe I shouldn't say this. Just been dealing with some tricky stuff at work with connecting up with other SaaSs.
SaaSs. Could you
talking about
define
SaaS
that?
products here?
Yeah, software as a service products.
Fun.
Yeah, sometimes the APIs don't quite do what you want them to do, and that is the life of a developer. Yeah, exactly.
All the time. And you're like, what's happening? What's not working? No answers either. It's just a black hole sometimes. Ugh. That is a good segue though, talking about work. It looks like you got your start in, I will say, like more traditional sciences. So how did you find your way into programming? What made you kind of diverge?
Yeah, so I've been programming for a super long time. I don't know, I grew up in the DC area. Y'all are familiar with that. And, there's like some TLAs and weird stuff going on. And I went to an elementary school that I think was like funded by some sort of weird grant. And they were teaching us how to program. Like in first grade, we learned how to type. And as soon as we learned how to type, we learned how to program.
I remember learning how to type in first grade, but not how to program.
This wasn't an era when like typing was still considered to be like secretarial work in a women's job, which is kind of it's kind of the tail end of that. Like it was maybe a few years before AOL came around, so that transition in the DC area hadn't quite happened. So yeah, that's that. So it was a very sort of like ahead of itself. My dad was just like a middle manager in the U.S. government. He also had a part-time job in the Navy. So one of his jobs in the Navy, he led a group that developed the first fully networked inventory system for the Navy. And so he was like, he called himself a technological midget, but he was good at, he liked to say he was good at talking to geeks. And so I think he appreciated that was like real. I was super lucky. I just had a bunch of like from a young age, people who were kind of pushing me into tech. My neighbor was the NSF project administrator who wound up getting the gravitational wave sensors up and running, the LIGO project. And he was insistent to my dad that he get me a computer. So, I was lucky to have all these like early influences kind of pushing me towards this stuff. But then I decided to become a chemist because I liked to work with my hands. Spent, did a whole PhD in that field. Was a Lyft driver for a year and a half after quitting science, which was also a pay upgrade. I made more money as a Lyft driver than I did as a scientist. And and then I decided that look, I can program, so why don't I try and figure out, like, I was in San Francisco, so I was like, why don't I try and figure out the startup scene and try and get a job, and started by doing some contracting work, helped like debug prototype computer chip, did some theoretical computer science. And then finally got a job as R&D at a startup and used that as an excuse to teach myself Elixir.
So that's a really interesting kind of origin story from the perspective of you went all the way to PhD. And chemical engineering, or was it just I don't know these words, biochemistry? And I noticed on your Twitter profile, you said you're going to get back to bio one day. So in these two tracks, the multi-universe of the Isaac world, is there an ideal? Is there a spot you'd like to be in? Is there like maybe a merging of the two that's like peak Isaac?
I think that like we're seeing that biotech has not really sort of embraced basically the open source concepts that like, information should be free. It's still like heavily encumbered by things like patents. I've always wanted to, having been sort of in sort of the more computer tech side and seen what that's done, I've always wanted to like do that with biology. I tried as a biologist. I've got some crazy stories of there was a Chinese lab that had just published the genome of some organism, and they were like, we're making this open access to everyone. And so we used their interface, and we're skeptical. And so I wrote a Ruby script to scrape the genome of this organism from their website, one HTML page at a time. And then like we got it, and then the next day they'd shut down the website, and it was very clear that they were just like open sourcing it just to say that they were open sourcing it, right? So I've used like computer tech in a quasi professional way in various exploits over time, running simulations of enzymes and stuff like that. And my dad always wanted me to do like some sort of combination of biology and programming, and I never really thought that was like the right way to go. I still stand by that. But I think that biology can like learn a lot from how we've done things. Drug prices are really expensive, and I think if we had a commitment towards like doing things without it, it can be a much better enterprise for everyone.
Yeah, I mean, even more recently with COVID, right?
Yeah, COVID,
they had to force them to be like, can you just make it available so actually more people can get vaccinated?
Yeah, I mean, I'm not sure that Moderna and BioNTech were. I think they voluntarily said that they wouldn't make it. I mean, who knows who told them to do what? But yeah, I mean, so we're seeing like little bits of this creep through. I mean, of course, like when the polio vaccine came out, that was not patented. Partially because we didn't have a concept of patenting vaccines back then. They were also like, this is important, so let's do it.
Yeah, we want to help people. How did Elixir catch your eye, if you don't mind me asking? I mean, it's relatively niche, and I've said that probably on like every single podcast episode, so I'm really sorry to everybody listening that I'm saying it again, but I still think it's true. It's pretty niche. How did you find it? What made you interested in it?
That's a good question. I'm actually kind of surprised that I wound up on it myself. Basically, like, I've programmed in everything from C to Ruby to Python to Perl, in dribbles over the course of many, many years. Probably of all of those, Ruby was the one that I liked the best. It did come to a head around 2000 and I want to say 9 or 10, maybe a little bit later, when it basically became really difficult to install Ruby. Like you just couldn't you couldn't do it right. Like maybe it was a little bit later, 2012 or 2013. You couldn't pull the correct Ruby package, and there was a Ruby 1.8, 2.1 debacle, and I mean, it just was no longer easy, and I kind of got sick and tired of it. And then I learned Julia, which really excited me because I was had a fairly strong math background and was interested in doing interesting math things. It got me through 2 contracting jobs that were very numerical in nature. They were shocked because there was like a 10,000-fold speed up, and we could deploy our code to supercomputers, which was much more challenging for the systems that they were writing in, which is Mathematica. And also our code looked exactly like what he had written in the book. So that was it worked out really well. But it's hard to get. It was back then. It was really hard to get Julia jobs, and so I kind of had dipped my toe in the functional programming sphere, and I guess I just was Google searching one day, like, what can I learn next? And it was suggested somehow, like Elixir got suggested to me by the Google Oracle or something like that, and it looked like Ruby, and it was functional. So I guess that was sort of what got me into it. And I mean, really, it's been the programming language that I have found the most joy in, like even more than Ruby. Ruby was known to be the programming language that is joyful, and like I find that Elixir is even more so. It's not perfect, but I've run across both in my code and other people's codes extremely frustrating patterns that sometimes happen. Like I would say at the 90% level, it's by far the best programming language experience that I've ever had, and I'm unlikely to move off of it.
What would you say your aha moment was with Elixir? Because I know Alex and I have said, plenty of times in the past that there was like a moment where it clicked for us. And, you say that you find the most joy in it. Did you have one? Is there a particular feature of Elixir that you really enjoy?
I can't remember any specific aha moment that got to me. I mean, there just have been so many, and none of them have been really like earth-shattering. It's like, oh, and I can do this too? Yeah, of course I can do this too, right? Those sorts of moments have just like piled up. The discovery that somebody else had built something in the Elixir standard library, in fact, so this goes back to our testing, which you guys did last week, how Elixir has support for asynchronous testing, and that's like really fascinating to me. And like I design, whenever I start a project, I design it from the ground up to have 100% asynchronous tests. It might not necessarily be the case for something where you're building a web service or something like that, but for my libraries, I always do 100% asynchronous, because that's important to me, because it guarantees that other people, when they try to use your code, you're going to have something robust and something that will work.
Yeah, I think in the previous episode it was about testing, but we talked about, was there a moment where a lack of tests kind of bit you and made you really find your appreciation for testing your code? And did you have a moment like that, or was this something that was kind of instilled within you early on?
I think I have an appreciation for the Elixir and the Elixir ecosystem because I've become better at testing. When I started off, I was not very good at testing at all. And I didn't have a good concept of, what sorts of tests you should write, when you should do TDD, it's okay to not do TDD. I like TDD, but I don't always do it. So I think I'm in between the two previous guests you had. Yeah, I mean, I don't think that there's any one thing in particular. Again, it's just holistically, I feel like it's made me a better programmer, and that's I have a lot of appreciation for that.
I would 100% agree with that. I think my first Elixir job, which was my job previous to this, or I guess two previous to this, made me a much better programmer, and was also the first job that I'd really had where there was a very strong emphasis put on testing. I'd either been in startup world where the pace you're moving at is just so fast. It's like, get it out the door, get that thing also out the door. And so everything is just higgledy-piggledy. Or my first job was at a pretty, like a 20-year-old company with a pretty old legacy code base with little, if no tests, right? And it's hard to then at that point prioritize going backwards and saying, oh, we need to write tests for this legacy code. And I think that Elixir has made me enjoy it. Yeah. I like the way you put that. It's made you a better programmer.
Yeah. I definitely feel the same way about that too. Like I definitely like TD. I can't speak. I like TDD a lot, but I also don't always do it. Time factor. But I always find that when I don't do it, it took me longer to write the thing than it would have if I had wrote a failing test first. Yeah,
it has a way of focusing you and getting you to write the minimum amount of code you need, and then you're like, oh, I'm done. I'm a person who will not always, but will often like overthink things. And just TDD is like a great way to just put blinders on yourself, and it, many times makes you productive because you don't obsess over all of the nitty gritty infinite possibilities. And it also, like, sometimes they'll say, you know what, I know this is a possibility, I'm going to wait for a customer to complain about it. Write yourself a little comment, this could break, hey. and then maybe that like weird shape in the database will never occur, and when it does, you push a patch and it's going to be okay.
Yeah, absolutely. Switching gears real quick, want to do a little spotlight on you. You do a lot of Zig and Zigler. Can you tell us what that is, what it's about, the elevator pitch?
Yeah, so I think it was about 2 years ago, I discovered, so Elixir is a high-level programming language, and so there are just some things you really don't want to do. And I can't remember exactly what I wanted to do as a NIF. So NIFs are, in the Beam virtual machine are ways to interface with native code. So basically,
what does it stand for?
Natively invoked function. I'm guessing. I don't even remember. Native interface function, maybe. The broader CS term that people typically use for it is FFI, foreign function interface. So it lets you write C code and compile the C code, and then your Elixir code or Erlang code will execute that C code and then come back and then give the result back to whatever code was triggering that function. And I remember looking at the NIF specification that Erlang provides and the docs, and just kind of like eyes glazing over. It's like, okay, this is not something I'm going to do. So previously I had done this in Julia. I'll say it's considerably easier in Julia than it is in the Beam and Erlang and Elixir. At some point, I must have learned about Zig, which is also a low-level programming language that seeks to be a replacement for C. Kind of in the community, it's often said that Rust is a replacement for C++ and Zig is a replacement for C. It's designed to address a lot of core problems in C. So you can't do things unsafely. So for example, integer overflow is a problem in C. So if you have an 8-bit integer and you go past 256, that you're going to have problems. And so that's one example of something that Zig will prevent you from doing, or going over the end of an array. So if you have like an array of 10 items and then you index into 10, it'll yell at you, it'll crash the program. And so you don't do that. As I started exploring Zig, what I noticed was that there's actually quite a bit of similarities between Zig and Elixir. So the way I think of programming Elixir is you have to remember that there are two different modes that Elixir is running in. So there's the code that exists in your def and def-p blocks, and that's code that's running at runtime. And everything outside of def and def-p is effectively a scripting language that you're using to build your program. So there's two worlds of Elixir. There's the compile time world, which is a scripting language that is used to assemble a fully running Beam program. And then there's the actual program itself, which is at runtime.
I've always kind of thought about the difference there being like the stuff in the EX files and stuff in the EXS files. Are you saying it's separated a little more on the nitty-gritty side? Is there a little more specificity there? Okay.
So in an EX file, so ignoring the EX files, which I think they're a little bit of but even inside of an EXS file, it's a little bit more complicated in my mind. I don't actually completely understand how the interpreter works. Just for the compiler, I think of, so even everything outside of def module and inside of a def module, and then everything that is outside of the def-p and defs is a script that's used to assemble. You can assign variables inside the body of a def module, right? And then what happens to that variable? It just disappears after, it doesn't exist after your asset has been compiled. So in that sense, it's a scripting language. You can write, you can do crazy things. You can load a file, JSON parse it and then find some field in the JSON and then use that to set something at compile time, right? So, and it took me a while to figure that out. I didn't fully appreciate that until maybe about a year and a half into using Elixir. Elixir has this compile time or comp time code, and there's runtime code. And Zig also has code that you run at compile time and code that you run at runtime. And you kind of have to train yourself to like see the difference between the two, because like Elixir, it's kind of, can be a little bit murky as to what's running when. But it's extremely powerful. The one thing is Zig doesn't have that Elixir has is macros, but it turns out you can do a lot of very powerful things without macros as long as you have compile time. Elixir, which has mix.exs, there's a build.zig, which is a code file that you use that provides instructions to the compiler on how to build your project. And I think that both of those concepts are really powerful and modern. So in the old days of C, you would use make, and now people are using CMake, and it gets really complicated. And sometimes C files are quite frankly inscrutable. Like, people have these macros that are designed to inject code that's weird, and depending on if you're using Windows or Linux, like the entire function header can change and it can get really messy. None of that in Zig. It's very clean because everything is sort of in one language that's easy to understand. Just as it is with Elixir, everything's in one language. Your build is in one language, and your compilation units are in the same language.
What's it like to write but then debug a NIF? Like, how do you go about doing that, I guess?
Yeah, it's hard. I don't have a good answer for that except write tests. And the approach that I take when I'm at least doing all of my Zigler stuff is I write just Elixir tests. And to make that easy, so Zig also has tests. You can write these tests in line. You write these little test blocks, and then it executes the code only when you're testing. What I've done is I've made those integrated into, much like how we have doc tests in Elixir. If you're writing your inline Zig code in Zigler and it sees this test block, it will take that, and you can write in your Elixir test file. You might have doc test some module. You can do Zig test, a module that contains your Zig code. It'll find all of the test blocks and then turn those into a set of tests that you run that are marshaled by XUnit. And so you have full seamless integration between your tests that are of Zig code and your tests that are of Elixir code. And so as sort of a guiding philosophy for Zigler, one of the things that I've wanted to do was to provide like a really tight integration surface between the two languages. So between Elixir specifically and Zig. So a good example of that is if you return an error from a function inside of Zig has something called a error return trace. So it's kind of like throwing an exception, but there are some very key differences that exist because Zig is a low-level language. But in debug mode, it generates a trace of which function was the first function that said I've got an error, right? And what I've done is I've integrated that with Elixir so that when that error exits the NIF and comes back into Beamland, it can find that stack trace and it will append the Zig stack trace on top of the Elixir stack trace. So when you see your error come out in your Elixir stack trace, it shows you all of the Elixir functions that you were calling and then what Zig functions you were calling and then where that error came from.
This is probably just because I've been doing a lot of Ecto stuff recently, but in my head, this sounds like when you join attributes together and you're like seeing data attributed to one model and then you've just attached it to another one that's like vaguely related to, and then you get to see all the information. That's really cool.
Yes. So this is a new feature. So to sort of, I guess this is a little bit out of order, but so Zig and Zigler were on version 0.7, And Zig just released 0.8, and so I'm currently in the process of bumping Zigler to 0.8. And so the merged error return and stack traces is something that's going to happen with the next release.
So if you had to break it down into like a one sentence for each thing, Zig builds into Zigler in what kind of way? Like, would you describe, you describe Zig as a low level language. How would you describe Zigler?
Yeah, so Zigler is a bridge between Elixir and Zig, which makes it super easy to build NIFs. And there are a few things that I really care about. So one of the things that I care about is I want to make code review easy. So if you have something where you have not too much Zig code, right? So you're not necessarily pulling in outside libraries. You just have a little bit of stuff that needs to be high performance. It's all in the same repo. So what you do is you write your Zig code inside of a sigil Z block inside of your module, right? Then that creates all the machinery that correctly assembles the NIF and then compiles it into your program. So your Elixir module has Zig code sitting inside of it, inside of the sigil Z block, inside of a code block. You can have it be a part of a single code review process without having to, say, pull a Zig library, or Rustler, I think, uses cargo. So you're pulling from the Rust repo. So if some change gets made over there, you have to like go to a separate like repository manager and then, okay, let's look over this code. I wanted to like make it as simple as possible.
That seamlessness is nice.
Yes, exactly. So seamlessness was a high priority for what I was doing with Zigler.
I think this sounds very cool, and I would say that I'm still kind of like wide-eyed, and I don't really understand it, but I now would like to actually know more about it. So maybe find me poking around in the docs sometime. I saw on your Twitter that you wrote your own disassembler. Is that true?
Yeah, so I think the thing is that like when you once you start like peeking at how deep the rabbit hole goes with the Beam virtual machine, there's like you find other things that are interesting, and then you can keep going. Right. So all right, I've got two pet projects that I want to sort of merge. Well, there's sort of a domino effect. So one led to the other. So Zig is capable of compile. One thing that is amazing about Zig is that it's really easy to cross-compile with Zig. So this is a major problem with low-level programming languages. If I'm on a Linux machine and I want to give you an executable that runs on you're on a Mac, how am I going to do that? And if it's a scripting language or like sort of a high-level VM language like Java or Elixir, usually I can just send you the code and then it will run. But if it's something that needs to be compiled to a single program, not necessarily so much. Go kind of has this down, but there are even places where you can't do this so cleanly in Go. And for sure, it's a nightmare with C. Zig solves this quite easily. So you can cross-compile Zig between architectures and between operating systems with no problems. Well, I mean, for the ones that are well supported. And moreover, you can use it to compile C. Quite a few people have found use of Zig as a drop-in cross-compiler for C programs. And so Hugo, which is a static site generator for which in Go, is one of the best ways to cross-compile it is using Zig. So, because it requires some amount of C, and that amount of C cannot easily be cross-compiled, even though it's in Go. So, I can't remember how I was getting into this.
All good. Maybe while we're paused there, actually, you just made me think of something. You've had a lot of experience with different languages, and I feel like you mentioned earlier that it was harder to write NIFs in Elixir than it was in Julia. Was that something you said? And I'm curious, is there anything missing from the Beam that would have made it easier? Or just in general, is there anything that you feel is like severely missing from the Beam?
No. So the reason why it's easier to call C from Julia is one, because Julia cares highly about high performance C because, they are working with scientific computing where every, clock cycle counts. And the priority for Elixir and the Beam is different. So we care about having robust and high uptime systems. And as a result, everything has to be interruptible. And so it's important for the Beam to be able to run some code and yank it and say, hey, you've had your share. Let's give some other task like its fair share of time. And so in order to accommodate that, there are a lot of things that the Beam has to kind of put in the way of executing low-level code. So when you're writing a NIF, the other major difficulty for the Beam is that we have a dynamic type system, right? So we have boxed types. So every value that you have in Elixir or Erlang is surrounded, like low level inside the VM, it's surrounded by, it's got a pointer and some metadata that says, hey, this is an atom, or this is a binary, or this is a list, or whatever, right? And that has to be unboxed on the other side when you jump into C land. And Julia just has some special ways of dealing with that they've addressed. But what I do with Zigler is I read the function header that you provide to Zigler, saying I want this function to be mounted into my module. It reads that, it figures out what the types are, and then does all of that unboxing for you. So you don't have to write that code. And then also as a little gift, it'll also type spec it correctly. So if you say I want unsigned 8-bit integer, the type spec will say 0 to 255 are the correct values. So maybe Dialyzer can catch you if you make a mistake.
You have gotten into the age-old question, types or no types for Elixir. It's a fun debate. We have it every other episode.
So I guess for me, part of Zigler was, hey, let's find all of the hard parts where it's easy to make mistakes building a NIF. And so where Julia has like a macro called ccall that will kind of smooth over all the edges for you, do something similar in Elixir where all of the hard parts are kind of just done automatically because you do not want to make those mistakes. And it will do the right thing. If you pass, 375 to something that can only go to 255, it'll say argument error. I think those things are kind of important to kind of handle magically, if you will.
You said pointer a minute ago, and I just had this like kind of scary flashback to one of my college computer science classes learning about pointers in C, and I was just like, oh no, I'm back. No, take me away.
We can take you away, Alex.
I still I know and I remember, but I do remember being truly just like, this is going over my head right now, and I wasn't ready. Maybe it's time to revisit it.
Yeah, it's some low level stuff, but it's not. I think if you get yourself into a mindset where like I'm ready and genuinely curious about how all this stuff works under the hood, you'll be ready to learn pointers. But I think it's perfectly fine to not learn that in the beginning.
Oh, thank you. I also think there's something to like going back to you learning how to type in first grade. There's something to when you learn something and who is teaching it to you that can be the really big difference in your overall experience.
Definitely. I had a fantastic CS teacher in high school who taught me pointers very, very effectively. And I actually used one of our homework problems as one of my interview questions. So,
wow. Well, shout out to that
That's
teacher
hilarious.
then. That's incredible.
Isaac, you did just briefly mention magic. Curious what your thoughts are on magic in the programming space in general, but maybe more related to the Elixir side of things and what you've experienced having worked with a bunch of different languages. Like, what is your opinion of magic in programming?
Yeah, so like this is one of those things where I'm probably going to get myself in trouble. I have kind of I have a love-hate relationship with magic. It seems like all of the libraries that I write have some splash of magic associated with them. So Zigler, obviously, there's a lot of magic. You take this like quote, like this string in the middle of your module, and you turn it into something that becomes a NIF. That's pretty crazy, right? And so there's a lot of macros, and there's a lot of magic going on there. I think I like magic when one, it's got to be predictable. So if you do something, it's got to make sense. It's got to you have to be able to like look at it and just say, oh, I have an idea of how that works. I remember when I was learning how to do databases in Ruby with active record, it would pluralize your tables for you. And that drove me up the wall. And I could never learn Rails because there was a lot of magic in Rails. And I was doing most of my Ruby web stuff in Sinatra, which is a lot like Plug. So, it took me a long time to actually figure out Phoenix. I started with Plug and wrote a lot of stuff in Plug and just never touched Phoenix until I was like, okay, fine, I got to do some live view and to make an admin console for this thing. So I learned myself some live view. Still, and there's still stuff that drives me up the wall. Like I don't understand Phoenix routes. And I've kind of been dragged kicking and screaming into that. And it's fine. It's a little bit frustrating because sometimes it's easy to wind up creating like compile loops where I've seen some extremely large and long loops, and often there's a Phoenix route involved in some brownfield projects that I'm working on.
Mix PHX routes, just the command, saves my life so much when I'm just not sure what's happening. If I don't know where to start at all, I'll go to the router. Or if I don't know what I'm looking at, I'll do mix PHX routes, and then I can see it all in front of me, and I'm like, okay, I have a starting point now.
Exactly. I mean, I actually did not learn to use mix PHX routes until like a few months ago, even. and then I was like, okay, fine. All this router magic is worth it because we get this one command that makes my life easier. But I still have like, I still have reservations. But I get it. I get why it's there, right? But the way that it does stuff is sometimes a little bit confusing. I'm gonna get myself into trouble here, but I don't love. Oh, I don't remember what it's called. There's a factory library that we use that I don't love. There's a little bit too much magic, especially when you start rewriting function names. That's, I think, the place where and so these days I've kind of started making small changes here and there in code bases where at least if some sort of macro creates a function, I'll leave some sort of breadcrumb in your import statement or in your use statement. There's some atom that like draws your eye to it and says, okay, when I search for this function that doesn't exist, whose definition does not explicitly exist in the module, here's where it came from, and then you can go and chase it through that macro. Import at only has become like, I've started sprinkling that everywhere, and I've started to like optimize for things like being able to search with global search, and just little things like that have become a priority because Elixir does give you a lot of like space to use magic for very like dangerous and or frustrating things. But on the other hand, when it's something like, you're using this magic to make things really safe and to make sure that errors don't happen, or to make something really painful, really convenient, I think it's worth it. And I'm glad that magic exists. I think we can wind up in danger sometimes where we try to dry a little too soon. And especially if we start using macros to start drying, and I'm kind of like, I'm not super into like using macros for drying anymore. I was in the past, but not anymore.
I have in my head right now, I don't know like the particular quote, but I'm just thinking about magic and like wizardry and warlocks and witches, and how like anything powerful can be either good or bad. It just depends on who is kind of wielding the power, right? So I think what you just said was very poignant. Like you can use magic to do really cool things, to really great things that are also very understandable and clear and concise, or you could do some funkiness and then you end up with a very confusing code base that's hard for people to walk through, hard for people to learn, makes code reviews harder. So it's just all in how you use the power that you have.
The quote isn't "with great power comes great responsibility," is it?
Well, that's from Spider-Man. I think I'm more specifically thinking. I'm more specifically thinking of like, are you going to be a Dumbledore or are you going to be a Voldemort? You just gotta like, you gotta weigh out the options.
Maybe this dates me, but like the reference that I'm thinking of is Disney's Fantasia with
I love Fantasia.
With Mickey and the brooms that he keeps like conjuring. They keep spawning. He spawns all these brooms, and all the brooms are like getting out of control.
That's and then he ends up with the giant broom.
Yeah.
That, like, it's like the mama broom. The mama broom is really mad that he's been abusing all the baby brooms. Oh, great! It's a great movie. It's also very strange, but I thoroughly enjoy it also.
There's something to the idea of like macros, like cloning code and like having little codelets that go to these little things that I think is like apt, and like, you know, you got to be careful because if you overuse this, if you use it in a frivolous way, you might get yourself in some trouble.
Yeah, just like Mickey Mouse. Well, Isaac, do you have any final plugs or asks for the audience? Maybe social media, where to find information on your libraries, things like that?
Yeah, so you can find Zigler on hex.pm. There's going to be an upcoming version soon, maybe in hopefully sooner than, I keep saying that and then I keep wanting to have to do like things for work. So that, you know, that's life, right? Soon. There are actually two projects that I'm kind of working on that I would like to try. So most of my projects up heretofore have been like fairly solo, and I've been good about like keeping them and keeping working on them, which I know it can be tricky. I just refreshed one project that uses magic that I use for work, which is a JSON schema parser, and I had started 5 years ago and never published to Hex, and finally it was like, okay, it's time, and I published it, and I like it now because I'm happy with it. But the projects that I'm looking for help on, and I think that other people might be interested in stuff like this. One of them is called Chiaroscuro. The idea is so this has to do with disassembly. As you were asking about before, I kind of got into Zig disassembly, Beam disassembly, and am interested in writing a Zig interpreter for it that can be run on the browser. And if you think about that, there's some interesting things about testing, like maybe you could deploy some Elixir code on the front end, and then also have fully integrated tests in your code base, which I think would be really cool. But it's like very hypothetical. I don't know if that's going to be like useful to anyone. But, you know, it's interesting, and I know that some people are interested in both like Elixir on the front end and might be interested in some neat compiling stuff. And the other thing that I'm working on is a static type checker for Elixir. So I know we were talking about types very briefly earlier. I think that we can do a little bit better than Dialyzer. And so I have some opinionated opinions about typing and how we could do better in Elixir. And so I am currently, as my third in the stack project, working on type analysis in Elixir, and I have an idea of how to use the disassembled Beam code and run some fairly nice type analysis on those and help you write better programs.
Here we are again, yet at the end, talking about types.
Always, it'll never end. And It'll never end.
It'll never die. No.
It'll never die. But yeah, so the two projects there are called Mavis, which is the type engine. I don't know if you guys get that pun, but I learned how to type from Mavis Beacon. The other one is called Selectrix, which is the type analysis engine. Also a pun.
Both of those sound fantastic, and definitely something that I would be interested in. So I'll keep my eyes out for the third on the rung. I get it. Life gets in the way sometimes. And by some of the time, I mean almost all of the time.
Yeah, and I just moved halfway across the continent, so that's been a huge time suck.
Yeah. Well, Isaac, I wish you luck unpacking. And also, thank you so much for joining us today. It was really great to have you on and get to talk with you. And that's it for this episode of Elixir Wizards. Elixir Wizards is a Smart Logic production. Today's hosts include myself, Alex Housand, and my co-host / producer for today, Sundeep Mient. We get production and promotion assistance from Michelle McFadden and Ashley Stotts. Here at Smart Logic, we build custom web and mobile software. We're always looking to take on new projects. We work in Elixir, Rails, and React, Kubernetes, and React Native. If you need a piece of custom software built, hit us up. Don't forget to like, subscribe, and leave a review. Follow @SmartLogic on Twitter for news and episode announcements. You can also join us on the Elixir Wizards Discord. Just head on over to the podcast page to find the link. And don't forget to join us again next week for more on Theme Magic.